All right, guys, so this is just a quick overview of Lab 7 and just kind of how to navigate it. So in terms of the PowerPoint, most of this it can actually be found on the PowerPoint for Lab 6. So let me just let that load. Actually, it's gonna, so right here. So most of the stuff for earthquakes and faults, and it's kind of tied into plate boundaries. Um, so most of that's going to be on your Lab 6 PowerPoint. So you should be able to kind of navigate what type of fault occurs with what type of stress, what type of boundaries what type of boundaries have what types of stresses, and things like that. So that stuff's going to be found in your PowerPoint, in the Lab 6 PowerPoint. I'll relabel it Lab 6 and Lab 7. Let's see here. Okay, yeah, so it's the Lab 6 and Lab 7 PowerPoint. So that's where most of the information for earthquakes are going to be. Now, I'm going to kind of go through question 2 here. It seems to be tripping people up. So what you're going to do is you're going to choose a zone. And I would recommend not making it too big because you're going to have a super high count. So you just choose a zone anywhere. It could be anywhere in the world. Ideally, you want to do it where you want to kind of have a mixed area where there's a good amount of earthquakes and then a good amount of free space. So like take here, for example. And you're going to you're essentially trying to find earthquakes in your region at different magnitudes. And the earthquake count you're going to use is going to be here in the corner where it says earthquake count. And the reason you want to note that number is because that's the number you're going to use. Essentially, that's the number you're going to divide by 25. So that's your number of events. Your earthquake, think of events as earthquakes. So your earthquake count is your number of events. And to find the number per year, because since you're looking at it through 25 years, you're going to divide it by 25. So you're trying to find how many earthquakes are at each magnitude. I believe it's 0.5 intervals or intervals of 1. So the magnitude of decrease. Okay, yeah. Decrease magnitude 0.5 intervals. So yeah, and you're obviously can end on 0.5. But yeah, so you're going to do this for each magnitude. This is just an example at the magnitude of 5.5. So how you do that, say this is your region. Again, the region is up to you. You're going to choose the region. And right now, this is my magnitude at 4. So what you're going to do is look at, start with 8.5. And you're going to look at magnitudes between 8.5. And we're going to apply. And now this one's got none. So it's going to be 0. So if this was your region, you would just put 0, and then 0 divided by 25 is 0. And that's how you'd go through this. And you keep doing that. You do that for 8 and all the way down to 0.5. And so that's kind of how you calculate the number per year. And it's usually going to be a decimal unless it's, a multiple of 25, which rare, but it's possible. But it's more often than not going to be a decimal. And so that's how you're going to find your earthquakes per year. Your number of events is going to be this earthquake count right here. And that's going to go in your second column. Oops. That's going to go in your number of events. And then you just divide that number by 25. And you're going to do that for this section, for question 2. And you're going to use those to answer question 3. Now, patterns can be anything. Patterns, maybe you notice, since you can see depth here, I'll go back to a better number. Let's do 6. So in terms of patterns, you want to look for maybe, there's more 6 magnitude earthquakes here, earthquakes with a magnitude of 6 here. And then hypothetically, let's say, there's earthquakes with a magnitude of 4 here. And so you notice, there's more worse earthquakes on this barrier as opposed to this barrier. And so things like that. You want to look for pretty much patterns in terms of either magnitude or depth. If you look at the scale bar here to the left, it monitors your earthquakes. It shows the earthquakes, their depth by color. So purple is obviously the lightest, then blue's a little deeper, green, yellow, orange, and then red's your deepest. I don't know if you'll see red, but yeah, you can look for patterns like that, patterns in depth, and then patterns in magnitude in your area of study, which is, again, it's going to be subjective and up to you. And so, and again, what you see in this here, what you see here is, again, patterns. You're going to look for patterns and use that to try to answer these questions. Maybe a certain river or certain land mass has more earthquakes than others. Maybe that can help you predict future earthquakes. So it involves a little kind of creativity. But yeah, and then again, likelihood of 7.0 earthquakes or greater. Again, that's going to be kind of what you see in your pattern in your area of study. And again, you don't want to make your area too wide, because then you're just going to, it's going to be kind of hard to record the data. And then you don't want to make it too small, because you don't want to never get any earthquakes. So just kind of gauge it to where you get a decent amount of earthquakes and kind of have a varying amount of topography, a varying land types, if you will, in your area study. Try to have a coastline and mountains and I don't know, things like that. So that's kind of how you're going to read and do that part. And then again, question 6 on, that should be in the Lab 6 PowerPoint, which is now labeled Lab 6 and Lab 7. You can also watch that video as well. Again, I kind of go over the faults and types of stresses found at which faults and which boundaries have which faults. Again, so that's going to be in your Lab 6 PowerPoint labeled Lab 6 and 7. So I hope that kind of cleared things up. Again, if you have any other questions, please feel free to reach out to me. And yeah, I hope you guys have a great week. Thanks.